To solve this data sufficiency question, we'll go ahead and consider each statement separately first and then together if needed. The question asks us what is the value of y. So in each statement we're given a quadratic equation that will have to determine whether we can find a definitive value for y. So essentially one value for y. Let's start with statement 1. So statement 1 tells us that we have y squared plus 3 equals 2y plus 1. So before we can solve this, any quadratic equation we would need to distribute and move all the terms to one side. So let's go ahead and let's do that for statement 1. We end up with a y squared plus 3 equals 2y plus 2, distributing the 2. Now let's move all of the terms to one side, preferably the side where we keep the squared term, the highest powered term, positive. So we'll move everything to the left-hand side here. Y squared minus 2y plus 1 equals 0. Because we have a quadratic equation, 0. Because we have a quadratic equation, odds are we're going to end up with two values for y. So we have to decide whether we're going to get one value that repeats itself twice, or we get two unique values, because we need to determine whether we can actually find one value for y to answer the question. So let's go ahead and continue to solve this quadratic equation. We'll need to factor. So to factor this quadratic equation, we'll look at factors of positive 1 that add up to negative 2. Our factors here are going to be negative 1 and negative 1. Multiplied together give us positive 1, and added together give us negative 2. So factoring, we end up with an y minus 1 squared equals 0. We could solve this completely. The solutions would end up being y equal to 1, and we end up with one definitive value for y. So we can definitely answer what is the value of y. It's equal to 1. So this statement alone is sufficient. So we can actually eliminate answer choice B, C, and E, leaving us with answer choice A or D. To decide which answer choice we'll end up getting, we'll have to determine whether statement 2 is sufficient or not. So let's go ahead and let's do that next. Considering statement 2, we're going to go ahead and try to solve just like we did before. So again, a quadratic equation, we'll need everything on one side to try and solve by factoring. Moving all our terms to the left-hand side, keeping our y squared positive, we have y squared plus 5y plus 6 equals 0. When we factor this quadratic equation, factors of positive 6 that add up to positive 5, we end up with a positive 3 and a positive 2. So we could break this apart into y plus 3 times y plus 2 equals 0. Solving this even further, each factor equals 0. So we can set y plus 3 equal to 0 and y plus 2 equal to 0. Thus, y is either negative 3 or y is negative 2. Since there are two options for y here with no other statements or information of how to narrow it down even further, there's two possible values of y. So we can't determine definitively which value it actually is. This statement alone is not sufficient then. So looking at our answer choices of what's left, statement 2 is not sufficient, so we can actually eliminate answer choice D, and our final answer choice would be answer choice A.